So welcome everybody to session 2 of our HPC user training series. This is the third or fourth year we've done this, and it's pretty fun to have the second session. Will be very technically interesting and challenging, and a lot of hands-on opportunities for you guys to get onto Expanse. There's a helicopter flying over, so if there's a lot of noise, I apologize. So this is just a little overview of our training program. Most of you already know about this because you've done session 1, but if you're new, I just wanted to give a brief update. So we do all kinds of training. This HPC user training is one of our longer running activities every year. We have workshops, we have webinars, we have institutes during the summer that run about a week each, and we invite you all to explore them and continue to develop your HPC cyber infrastructure capabilities. So everything's pretty much free. We do charge some registration fees for some of the longer running activities, but we do have scholarships for those. And we also have the HPC Students Program. So I'll talk about that in a moment. So this year we're having the 2 sessions. We're now in session 2. We cover a lot of skills for everything from, what's an HPC system to machine learning and everything in between. This session, you're going to learn a lot of more detailed how to write code and parallelize it. So what we call, hands-on for coding people. So we have an exciting agenda with the CPU and GPU and MPI and OpenMP, threads-based computing, and including some focus on GPU with NVIDIA technology people giving some training at the end. We have a lot of student activities. So one of our focus is bringing students into this profession. So we have internships, some are paid, some are volunteer. You can, for example, for this session, you can get a co-curricular record credit. Just contact myself or Cindy, and we'll let you know how to do that. Mainly, you come to all the presentations and do some of the work that the presenters suggest for you to do. We have the Supercomputing Club. Join that. You can also find out about that on our HPC students page. The URL is down below. This spring, the students are hoping to build a Raspberry Pi cluster. So get in touch with the club to get involved in that. We're working on our student cluster competition team, which is done at the supercomputing meeting. And we also sponsor student volunteers to go and work at the competition, at the meeting. Okay, student cluster competition happens every year. If you're interested in it for next year, we've already started building the team. Take a look at these links and see what this is all about. And accomplishments, we did virtual last year. We're hoping to do it in person next year. And then just concluding with a slide of the mentors that put in a lot of time and effort to help do this program. You can contact them. I'll add in Christopher Kuipert and Zoe's connections, but for presentation, feel free to contact the mentors or myself. And with that, there's some key links. Thank you for joining us in session 2, and I hope you guys have a lot of fun. And these are our sponsors. Okay, Cindy, I'll turn it over to you. Our speaker, I'll turn it over to Bob. And Bob is the Director of Education and Training at SDSC, and he will talk about Jupyter visualization on Expanse. Bob, I think you should be able to share screen now.
Okay, great. Thank you, Mary. So just quick clarification. The visualization, it's not limited to Expanse, and a lot of what we're going to do today, you could do on your laptop or your on any Jupyter Hub server you have access to. But that said, you can definitely use this on Expanse and maybe integrate some of the visualization into your workflows. So I'm going to start off by sharing my presentation. I have a very, very short slide deck for today, because most of what we're going to be doing is really just walking through some Jupyter notebooks I put together. So as Mary said, I'm the Director of Education here at the San Diego Supercomputer Center. Been here for a long time, go back to 1997. Actually, absolutely love it here at the Supercomputer Center. Worked in a wide variety of projects and scientific applications over the years. And I'm not really a viz expert, but I find though that for the work that I do require some visualization skills, put together plots, charts, other figures for papers and presentations. So for an overview today, we're going to briefly explore visualization in Jupyter notebooks. And we're going to be doing this both, we're going to be doing this both in Python using a package called Matplotlib or Matplotlib, and in R using something called ggplot2. So I'm going to guess that most of you probably have some Python programming experience, unless you're from the social sciences. You're probably not working in R. But that said, I don't think you need to be a programmer. You don't need to have intimate knowledge of these languages in order to do the examples. And in fact, you should be able to modify the examples with very, very minimal programming experience. So I'm personally partial to Python, and I'm going to spend most of my time there, but I'm also going to touch on R, since some of you may have workflows developed using R. And this ggplot2 package that we're going to cover is extremely powerful and very popular with visualization experts. So the motivation for this talk is that doing your visualization in a Jupyter notebook is going to make it easy for you to interactively tweak parameters and get your plots just the way you want it. But also by having your code in a notebook, it's going to allow you to easily automate repeated visualization tasks. And then also if your notebooks, if you're also doing computation using the notebook, it's really easy to integrate your visualization with your computations, especially if you're working in R or in Python. And if you have any questions as we go along, feel free to post those into the chat. All right, moving on. And I'll take the, Cindy, if you could take these links and post them into the chat, that would be great. You should have seen this earlier, that we have links to the GitHub repos, what I call Python series and R series. And in both of those repos, there's a lot of other content beyond the visualization. We're going to be looking at the Matplotlib IPython notebook in the Python repository and the ggplot2 in the R repository. If you are in the process of learning these languages, though, I would encourage you to go through some of the other notebooks in those repos. One point that I noticed is that you may need to install the Grid Extra package to do the final examples in the ggplot2 notebook. And then finally, running the notebooks, I'm sure that a lot of you already have experience in using notebooks. If you use Anaconda, which gives you a whole slew of packages, or many of the Galileo implementations out there, you'll probably have all the packages that you need. The only exception was that I had to manually install the Grid Extra R package when using the Engage Lively Galileo implementation. And if you are using Galileo, which I'm going to be doing today, I suggest that you choose the data science environment, since that allowed me to run all of the Python and the R examples. And I also found that the SciPy environment worked if I was just doing the Python notebooks, but it didn't have the support for R. And with that, I am done with my slide deck. Are there any questions before I move on? Oh, okay, there's a question here from Maria. How about Julia? I heard some people are looking into it for some data analysis and HPC flows and are having good experiences with it. Unfortunately, I don't have any real experience with Julia. I just did a little bit of tinkering, but I would be surprised if Julia does not have visualization packages that are that give similar functionality that you find in Python and R. Keep in mind though that the Julia, the developer community, is much smaller than the Python and the R communities, so you might not find as much capabilities. But yes, oh yeah, I was yeah. Sorry, Maria, if I misinterpreted your question. So I was referring just in the context of the visualization. But Shinji, if I'm pronouncing your name correctly, yes, Julia can definitely be installed. And in fact, the J in the JU in Jupyter comes from Julia. All right, with that, I'm going to go ahead and share my screen. So right now I'm on my GitHub page. If you want to download these repos, and you forgot the link, you could just go to Python series, and then if you look at a listing of all of the packages, all of the repos, you'll also see you scroll down, you'll also see the R series a little bit down the list. Yep, actually made it to the second page. Okay, with that though, we're gonna go back to and Cindy. So we're gonna take a look at Matplotlib. So I'm doing this in Galileo. And let me just give myself a little more space. I'll close that. All right, so there are multiple ways to do plotting and charting in Python, and I'm going to focus on what I think is one of the most popular, very, very powerful, very user-friendly. It's called Matplotlib, and we're going to use this to generate some basic types of charts. We're going to go into scatter plots, line plots, bar plots, and histograms in pretty good detail. A little bit of background that you may or may not be interested in. Matplotlib, the software architecture is that it has 3 layers. There's a back-end layer that renders a plot to a screen or a file. There's an artist layer that defines the containers and the primitives. So things like figure axes and subplots and so on. And then finally, there's a scripting layer, which we're going to be using to interact with the back-end and the artist layers. And for the scripting layer, we're going to be using something called pyplot. And a little bit, talking just a little bit about the syntax we're going to be using. And I'm not sure why they do this, but Matplotlib has 2 ways to generate figures. It's what I'm going to call the basic or elementary approach that involves calls to the Matplotlib pyplot figure method to create a new figure. And there's also a more advanced approach that starts with a call to matplotlib.pyplot.subplots method. And this returns a figure object and 1 or more axes objects. So, I've taught this, this topic a number of times, and I originally started off with the basic approach, but I found out though that there were some limitations to doing that. There are a couple of places where using the basic interface, I just ran into some dead ends where I couldn't do everything that I wanted to do with my plots. I didn't have that fine-grained control. The other reason I'm going to go with the more advanced approach is that a lot of the answers that you're going to see on places like Stack Overflow are always given in terms of this more advanced interface. So before we get started, we have a little bit of boilerplate that we need to execute. We're going to set Matplotlib inline. We're going to import Matplotlib, and I'm going to get the Matplotlib backend. And then I'm just going to import Matplotlib and import NumPy. Take a look at that. Right. And now I'm just going to define a few lists that I'm going to use in my examples. If you're not familiar with Python, all I'm doing here in these lines is I'm defining a few lists. I'm using Python's list comprehension syntax. So X is just going to be a sequence of numbers from 1 to 10, and W, Y, and Z are going to be X raised to the 1.5, 1.75, and second powers. So just to show you what one of these vectors looks like, there's an example of W, which is X to the 1.5. So we're going to start off very simple. Oh, and I should have pointed out that in the cells, generally, I'm going to begin with the basic syntax commented out. If for some reason you decide that you would rather use this basic syntax rather than the more advanced syntax, you can. But my examples, though, as I work through these, are all going to be based on this more advanced syntax using the subplots method. So first thing I'm going to do is I'm going to call the subplots method, and that's going to return that's going to return two objects. There's going to be a figure, and there's going to be an axes project. So the figure you could think of as the entire thing that we're generating, and it can involve multiple elements and multiple plots. Axes is a little the terminology is a little misleading. An axis you could essentially think of as an individual graph. So we're taking axes and we're plotting data against it. And we're going to start off using the scatter method. So we're going to call that for the axis object, and then finally plot.show to display the figure. And when I do this, I've generated my first figure. And just let me get a quick show of hands. Who is following along in their in their own notebook? Okay, I'm seeing a bunch of hands, a bunch of thumbs. Excellent. Oh, saw one hand go down. Okay, great. So it looks like there's a mix. That there are a handful of you that are following along, and others who are just observing, and that's fine. You could do this either way. So there we go. We just created our first plot. We have a again the call to the subplots method. We're going to call the scatter method, and finally we're going to show the plot. And already, with just 3 lines, we have a very acceptable plot. Now we're going to spend some time diving into tuning the features of this figure. So we're going to be following the same pattern throughout, where we are calling methods for the on the axis object. So, for example, after we call scatter, we can now use the spines method to turn off and on borders of our plot. So in this case, I'm going to set the top and the right axes so that they're not visible. So now we've eliminated the top and the right side. I could get rid of all of these. It's going to be a strange looking plot, but if that's what you want to do, you can go back. Make that look a little more normal. We can also plot multiple data sets on the same graph with multiple calls to scatter. So this is going to look like my first example, except instead of just plotting X versus W, I'm going to plot X versus Y and X versus Z, and we'll display that. So there we go. We now have a scatter plot displaying 3 data sets. All right, data points are assigned default sizes, shapes, and colors. And as you might expect, we can override these defaults to customize our graph. So what I'm doing here is I'm going to add I'm going to add a color. C stands for color. I'm going to set size. S represents size. And then finally, marker is indicated by abbreviations such as S, caret, or plus for square, triangle, and plus sign. So we'll go ahead and show that. We can see that we've now customized our plot a little bit more, rather than relying on the defaults that were chosen chosen by Matplotlib. We've instead customized the marker sizes and the I'm just going to be a minute. It looks like my server had timed out. I might have had that open for too long. So just give me a minute while I relaunch. Okay, good. It picked up where we left off. Oh, sorry, actually, it didn't save that last one, so let me regenerate that. Before I move on, are there any questions? Okay, if not, I will continue, but again, at any time, feel free to post in the chat. So just to show you a little bit more about the customization that we can do. In the previous plot, we set all of the markers to be uniform for a particular data set. So when I was plotting X versus W, I set all of those markers to be smallish red squares. I set for X versus Y, I set them all to be medium-sized blue triangles and so on. But I could actually set these values by point. Instead of specifying a scalar value for color or size, or I think also for marker, although I haven't experimented with that, you can actually pass lists. So here I'm going to set the color for the first 5 markers to be red, color for the next 5 markers to be black. And I'm only going to be plotting one data set, but I'm going to allow the size of the markers to grow over the course of the sequence. So if I execute this, you can see that we get the expected results. Red circles for the first 5 data points, black circles for the next 5, and increasing in size. So just make that a little more dramatic. And then finally, the next step we want to take is to add titles and axes labels. So again, we're going to be operating on the axis object, and we're going to set the labels using the set X label, set Y label, and set title method. So now we have a graph that's almost ready for publication. We have our axes labeled, and we have a title. So you notice that it's very easy that we can build up our figures incrementally. We don't need to do everything in one great big long command. We plot our data sets, we set parameters of those markers, we add labels, and so on. And then another enhancement that we could do is we can set the limits on the axes. So you notice that Matplotlib is great about automatically choosing reasonable ranges for the X and Y axes. Basically, it's looking at the minimum and maximum values in both the X and Y direction, and then giving you a little bit of padding. But if you want to, you can override that. and you can set axis limits. So now we're showing our data on the x-axis from 0 to 15, and on the y-axis from -5 to 150. Now you might be wondering why. Now you might be wondering why we may. Yeah, I'm not sure why I'm getting those messages from Galileo. I might have a second session running somewhere. So one reason that you may want to do this, and we'll get to this at the end of the presentation, is we may be creating composite figures with multiple plots, and with each data set having its own range of values. It might make it a little bit hard to interpret the results unless we manually set the ranges. This will allow us to more easily compare the multiple subplots. Okay, and one more enhancement that we can do is we can actually use log axes. So in this case, I'm going to set the y-axis to be log. By default, that's going to be base 10. And I'm going to set the scale for the x-axis to be log base 2. So if we go ahead and plot that, you see that we're now using log axes. This is really handy if you are plotting data that you expect to follow a power law. For example, the data sets that we're using now, which is x to the 1.5, 1.75, and second powers. This is also really useful if you are plotting scaling data. So over the next couple of weeks, we're going to be getting into parallel computing using OpenMP and MPI. And if you're plotting runtime as a function of the number of cores or the number of compute nodes, it's really handy to do this on logarithmic axes. And then finally, I should stop saying finally, there's a couple more steps we're going to do. We're going to add a legend to our figure. This just adds one new line to our cell. We're creating what we're calling the legend method. We're giving the legend a title. In this case, we're going to say that the frame, we're going to set the frame around the legend to be false. And the one other thing we needed to do was when we called scatter methods that we need to include a label. So example here, this is the label that's going to be used in the legend for the first data set, for the second one, and for the third. So we'll go ahead and execute that. We'll see that we now truly have a complete graph. We've got our axes labeled, we've got the title, we've got a plot legend, and we have our data. So let me pause there. Are there any questions about what I've done so far? Oh, we got a question here from Anmol Kapoor. Does the legend support LaTeX formatting? Yes, it does. In fact, we're going to be getting to that in about 5-10 minutes, and I think you're going to love the capabilities that we have here. Before we do that, though, we're going to shift gears, and we're going to look at a different type of plot. So far we've been doing scatter plots. Matplotlib has a separate method for doing line plots. And often we, let me just check it again. Yeah. So often we tend to conflate scatter plots and line plots, but they really are very different things. You're gonna have some more flexibility, excuse me, more flexibility with the scatter plots in terms of controlling the properties of the individual points. For line plots, you only want to use them when it's data that naturally follows a trend. So for example, if I would go back to my childhood and I want to plot my weight and my height as a function of time, that would make sense to do as a line plot, since the points are temporally related. But with the line plot, we also have some new features that we didn't have with the scatter plot. So again, a very basic line plot is going to look a lot like what we did for the scatter plot. As always, we're going to start off with a call to the subplots method so that we return figure and axis objects. We're then going to call, instead of the scatter method, we're going to be calling the plot method. And we're going to pass it the my x and y, or in this case, x and w values. And when we do that, we now have a basic plot. Any number of XY pairs can be displayed on the same plot. But what's a little bit different with the plot method compared to scatter is here, it's going to be a single call to plot. So it's going to be any number of XY pairs. So here we're going to plot X versus W, X versus Y, and X versus Z. And there we go. We're seeing that we now have our three that we have our three plots on our three curves on the same graph. As you would probably guess, we have a lot of control over things like line color, marker shape, line style. And the way we do this with the plot method is we're going to pass an additional string argument for each XY pair, and it's going to be of the form the color abbreviation, the marker abbreviation, and line style. And if you go to the plot.plot documentation, you'll see a full listing of the abbreviations and the styles. So what we're going to do now is customize our plot a little bit. For the first data set, we are going to plot with a red line using circles and using a solid line. For the next data set, X versus Y, we're going to use a blue line, squares, and dotted lines. And then finally for X versus Z, we're going to use a green line with triangles and a dashed line style. So there we go. All right, any questions so far? All right, so getting to the getting to the question that Anmol posted earlier, does Legend support LaTeX formatting? Yes, it does. And in fact, it goes beyond just the Legend. You can use the LaTeX formatting in any of the components of the graph that involves strings. So this is kind of contrived, but what I've done is I'm going to use some LaTeX formatting in the X label, get a Greek letter in there, in the Y label, and then in the legends, I'm going to use mathematical superscript notation. Now, if you're not familiar with LaTeX, don't worry. It's not essential for this session. But if you look in my Python series repo, there is a notebook in there that explicitly addresses LaTeX formatting. So it's a LaTeX could be very, very complicated. It's not used just for mathematical equations. It's used for the entire formatting of the document. But the math syntax is actually very, very straightforward. Greek letters, to get them, you just precede the name of the Greek letter with backslash, capital O for an uppercase omega, lowercase l for a lowercase lambda, and your equations just have to be delimited by $signs. So Matplotlib will look at anything between the $signs, and it will render that as LaTeX. So if I go ahead and plot that, so here's the same plot that we saw earlier, but it looks a little more professional. We now have proper subscripts in the legend for x to the 1.5, 1.75, and x squared. And in this case, I just kind of threw this in. It doesn't mean anything, but I was able to add the capital omega and the lowercase lambda for the axis labels. And just also want to note that all of the stylistic axis methods that we use for the scatter plot also apply to the line plots, and you'll see that we can also use them for the other chart types. So just like before, we're setting axis labels, we're setting titles, we're setting legends. All right, any questions before we move on? Check the chat. All right, with that, I'm going to move on to bar charts. So the Matplotlib bar chart method behaves much like the other plotting methods we've seen so far. And the example below, I'm going to show the results for a hypothetical hot dog eating contest. And if you're wondering about the names, Bob, Jorge, Esteban, Mariano, and Mahidar. So of course, I'm Bob. Mahidar is one of my colleagues here at the Supercomputer Center, who you'll be seeing, I think, over the next couple of weeks. And Jorge, Esteban, and Mariano were staff at a university in Costa Rica, where we had given this workshop a few years ago. So to create my bar chart, I'm going to generate some new data. I'm going to get a list of people. These are going to be used to label the data. We're going to get the positions of the bars. This is going to be list XPOS. And I could have just set this to 1, 2, 3, 4, 5. I wanted to automate the process in case I added on an extra name. So this is just creating a list of integers equal to the size of my list of people. Next line is going to be the height of my bars. In this case, this was the number of hot dogs eaten. And I want to distinguish between Team San Diego and Team Costa Rica. So I'm going to associate the color blue with myself and with Mahidar, and the color red with Jorge, Esteban, and Mariano. Just like we did before, every plot is going to start off with a call to the subplots method, which is going to return a figure and an axis object. In this case now, we're going to be calling a new method, and this is going to be the bar method. First two arguments are essentially going to be my X and Y. So we're passing the X positions, the locations of the bars. Hot dogs is going to be the value that I'm plotting. I'm going to align each bar, what we call centering it, so the bar will be centered at each of those ticks. And I'm going to pass in an array of colors. I could have passed in a scalar here. I could have said, red or orange or blue. But in this case, I'm passing in a list of colors so that I could individually tailor each bar. I need to set my X ticks, and I'm going to set the label for the X ticks. So each bar will be labeled by the person, and then we're going to use methods that you've seen earlier for labeling the Y label and the title. So we will go ahead and plot that, and you can see the result of our hot dog eating contest. So we can also, like we did with other methods, we can plot multiple data series on the same figure. So what I'm going to do now is extend our example a little bit so that we look at not just the number of hot dogs, but at the number of pies. So it's going to be a hot dog eating contest and a pie eating contest. In this case, I'm going to have two calls to the bar method. This is going to be just like what we did with the scatter plots. The first one is going to be for the hot dogs. The second one is going to be for the pies. And I'm adding one new feature in here where I'm specifying the edge color. Normally, you don't need to do this for a, did I do that earlier? Let's see. Yeah, no, normally you don't need to do this for bar plots, but for this addressed a small bug that we found in an earlier version of Matplotlib. So if we go ahead and plot that, we will see the results of our hot dog and pie eating contest. Now I should note that subsequent calls to the bar method, we essentially paint the results over what we had earlier. So as an experiment, I'm going to swap these around. I'm going to plot pies first, followed by hot dogs. And if we see if we look at our new plot, we'll see that the hot dog results were completely obscured. And that's because for each participant, the number of pies eaten was larger than the number of hot dogs, and that second set of bars ended up covering what we had earlier. Let me just add. So a good way to get around this, you know, in this particular case, we can plot it in this way since the number of hot dogs is always greater than the number of pies. But in the general case, we're going to take, if we're plotting multiple sets of data, we're going to want to tweak our figure a little bit so that our bars are narrower and don't overlap each other. So what I'm going to do is, for the first data set, for the hot dogs, I'm going to shift the positions a little bit. So instead of using XPOS, I'm going to take XPOS, I'm going to shift each of those bars by 0.2 units. And then I'm also going to make those bars a little bit narrower. And then for the second data set, for the pies, I'm going to do something similar, except in this case, I'm going to shift the positions of those bars just a little bit to the right, 0.2 units to the right. Again, this set the width narrower. And in this case, we have a result. And you know, I'm going to recommend if you're not doing this now or maybe later, you know, just play around with the parameters. I had to, you know, experiment a little bit to get these where I wanted them. Yep, basically do it like that. And the your advantage again of doing this in the notebook is it makes it really easy for you to you know, tinker with your graphs, get things just right, but also you've saved the recipe for making that figure. So I don't need to keep notes. I don't need to write down widths or anything, or go back and recreate this, say, in an Excel spreadsheet if I'm generating graphs there. I've got the full, I've captured the full recipe for my figure. Okay, I'm gonna explore one more feature in the bar graphs to show just the degree of control that you have over these figures. So let's say that we gave each participant a longer name. So we could have included our last names or maybe our location. So we now have Bob San Diego and Jorge Costa Rica, so on. If I take that and let's just paste it in here. And I plot, you'll see what's happened is that my labels are so long that they're running over each other. And that's gonna make, it looks really bad, it's difficult to read. So what we did here is we added one new feature to the graph. And that is, we took the tick labels and we rotated them 45 degrees. Now I'll admit, this isn't something that I figured out on my own. I was wondering how to do this. I did a search, believe found the answer in Stack Overflow. We're looping over the ticks, and then we are rotating each of those labels. And in this case, we now have something that's more visually appealing. So before I go on to histograms, do we have any questions? Okay, and is everybody following? Anybody getting lost? All right, I will take silence as a good thing. All right, so we're now going to move on to histograms. You could ignore the comment about if you followed my NumPy tutorial. That was an earlier notebook that we used as part of a whole series Python training. But NumPy, it does have a histogram method, but I'm going to recommend that you use the Matplotlib histogram method instead. So it both generates the histogram data from the input data, and it renders the results. So you don't have to worry about actually constructing the histogram bins. So for this example, I'm going to just build a couple of lists of 10,000 and 5,000 normal deviates. If you're not familiar with the syntax here, don't worry, that I'm just using NumPy's random package to generate the data. And then I'm going to plot this in a histogram. So I'm going to take that first data set, the 10,000 random deviates, and I'm going to plot this as a cumulative histogram. As always, we're going to start off with a call to the subplots method, returning a figure and an axis object. And now we introduce one new method. This is the histogram method. So we have the data that we want to plot. We have the number of bins. In this case, I set cumulative to true. We could have set that to false also. I'll show you what that looks like. And then we can set edge colors. Let's call this red, blue, and there we have our histogram. And we can also plot multiple histograms on the same figure. So in this next case, here we make a single call to the histogram method. I'm going to plot both data sets V1 and V2. I have a list of colors, green for the first data set, purple for the second one, and we're going to use 15 bins. And let's go see how that looks. So there we go. We've got our results. And if we like, we could also do that using cumulative plotting. Okay, so in this case, we've been plotting the histogram data side by side. We also have an option for stacked bars. So if I look at this argument that I added on here, hist type equals bar stacked. And we have a different way of plotting results. Okay, so let me just pause again for a minute. Are there any questions? You know, what I'm going to do is we are just about at the top of the hour. So why don't we take a quick 5-minute break? I'm going to set my watch. We'll come back in 5 minutes. Anybody needs to go ahead, grab a snack or warm up some coffee, go ahead, and then we will come back. In fact, you know what? Let's just make it 5 minutes past the hour. So see everybody again at 3:05. Okay, it is 5 past the hour. I'm just going to give it 1 more minute to make sure everybody's back. Happy to see the attendance hadn't dropped off for the last 5 minutes. Glad that you're sticking around late on a, well, I guess not late, but on a Friday afternoon. Okay, so we'll pick things up again. So, Arthur Feeney had a question that was, can one edit the range or the width of the bins, or just the number of bins? So by the range, I imagine you mean the range of values that the bin encompasses. And if I understand the question correctly, that will be based on the extent of the data and the number of bins. And I wrote here, I'll see if the width of the bars can be modified, and it can. So it turns out for histograms, and I hadn't done this before, but you can manually set the width of the histogram bars. So by default, by default, the bars I think will be automatically set so that they're just barely touching, but you can override that. The one thing though that doesn't appear that you could do is to set a vector of, or a list of widths. So when I try this, it's telling me that it's produced an error. So if I'm plotting multiple data sets in a histogram, they all need to be the same width. Okay, and then there's another question. Yeah, and there's a question from Maria. Is logarithmic scaling used in plots other than scatter plots? Are there any other scaling methods that are used? So I believe that you could use logarithmic scaling in any place where it would make sense. Definitely in scatter plots and in line plots. And I'm going to do an experiment right now to see if it can also be used in a histogram. Just go back and do a quick cut and paste. Okay, there we go. I have no idea if this is going to work, but let's give it a try. Yep, you can. So I'm gonna say that probably in any plot where a logarithmic scale would make sense that it could be done, And in terms of other scalings, I'm just not aware of anything other than linear or logarithmic. But do keep in mind though, for the even for the logarithmic scaling, that there's a lot of flexibility there, since you can set the base. You get 10 by default, but you can, if you want, you could even set it to something weird like base 3. Right, thank you. All right, so we're going to move on then. We're going to talk a little bit about colors. I'm probably the worst person to talk about color. I don't have a, I don't have an eye for color or design, hence my examples with blues and purples and greens. But for those of you who are into color, you have a lot of flexibility. So up till now, we've been working with basic colors, red, blue, green, purple, etc. But Matplotlib allows colors to be specified in a variety of formats, including hexadecimal RGB strings. So you've probably stumbled across these before. It starts with a hash, and then 3 pairs of hex digits to specify between 0 and 256 each for the RGB. I'm not sure. There's probably a way that you could specify CMYK also. And then there's also the XKCD color survey format, where you can specify colors using intuitive names like dark purple and aquamarine. And if you go to, if you follow either of these links, the first one for Matplotlib, the other for XKCD, it will give you a full listing of the colors and how to use them. So I'm going to just go back to my histogram example again. We're going to set a couple of colors using the hex codes, and a couple of colors using the XKCD colors. Here we go. All right, so just talk a little bit about other chart types. So with what I've covered, oh, I see there's a question here. Oh, yes, excellent point, Carolina. There are colorblind friendly palettes too. Yes. So if you are, if you're doing something for publication, especially where you need a whole palette of colors, like if you're doing a heat map, yes, I definitely recommend going with the with palettes that are colorblind friendly. In fact, I had worked about 10 years ago with a structural biology group, and one of the structural biologists on our team was colorblind, but he still managed to create some really beautiful some really beautiful renderings of viruses and proteins using these palettes. All right, so I'm going to talk a little bit about the other chart types. I think that scatter plots, line plots, histograms, bar charts, these are going to be the ones that you're going to all the time. But I suggest if you're really interested or if you have the time, go ahead and check out the Matplotlib Gallery for more options. So I've got the URL here in my markdown. Lots and lots of other things that you could do. All different sorts of graphics, lots of great ways to display your data. And if you go to this gallery, it essentially provides you recipes that you could use. So as I'm working through these examples, I have to admit, if I were hard pressed, I don't know if I could write any of these from scratch, even though they're fairly simple. I use this notebook essentially as my cheat sheet. So whenever I need a bar chart or a histogram or so on, I go back to this, I cut, paste, and I modify what I need. And you'll be able to do the same thing with the gallery. So we're going to start off with a pie chart. We're going to imagine that the United States is just 5 states, the most populous: California, Texas, Florida, New York, and Illinois. And we're going to assign them populations, which I think are pretty accurate. These are in the millions, ranging from 39 million in California to 12 million in Illinois. We're going to give the states labels. We're going to use this explodes feature in order to pull slices out of that pie chart, and we're going to assign colors to the wedges. Again, as always, we're going to start off with the subplot, with the call to the subplots method. And now we're going to apply the pie method to my axes. So we're going to be passing in the populations, labels, an optional list of explode values, an optional list of colors. In this case, I'm going to set shadowing true. I don't know why this is not the default, but if you want to get a round pie chart, you need to set the axis. You need to use the axis method and set it to equal. So there we go. We've got a chart of our state populations, and we pulled out California. Just to show you what happens if you forget to set axis equal. Oh, actually, that did work okay. That must have been, I think there was a quirk or a minor bug in a previous version of Matplotlib that required this. We can modify the values for the explode values. So that we can break things up exactly the way we want. Another way to display this kind of data, and I see this a lot in articles in the biomedical literature, is to, instead of a pie chart, modify it a little bit to turn into a donut chart. And I believe this is something that I found back here in the Matplotlib Gallery. So I'm going to generate a pie chart just like I did before, but now I'm going to add a couple of circles to make this look like a donut. So I'm going to have a circle at the center where it's going to be centered at my pie chart. We're going to give it a radius of 0.6. The color of the edge is going to be black. It's going to be filled white. And then we just have a call to the GCF method and the add artist methods. Again, I'm not too familiar with these. This is something that I got out of a recipe. And then we're going to create another circle, this one at the edge of the pie to provide a border. So once I do this, you see I've now taken my pie chart and displayed it as a donut chart. So any questions about pie charts or donut charts? All right, if not, we are going to wrap up the Python section with subplots. And this is one of the reasons why I went with what's considered the more advanced syntax right off the top. I don't know a good way or an easy way to generate these multi-panel figures using the basic syntax. So we're going to start off. Let me just redefine some data sets. I'm just going to add one more. I'm going to have a V, W, Y, and Z. And now if we want to plot a pair of figures side by side, so two panels within my figure, I'm again going to call the subplots method. But before, where I had no arguments, I'm now going to pass a pair of values which describe the layout of the chart. So here, by passing 1, 2, that means I want 1 row and 2 columns. Also notice that instead of returning a single axis, I'm returning a list of axes. So since I have 2 subplots, I am going to have two axis objects. And now I'm going to use axis 1 to do a scatter plot of X versus V, and axis 2 to do a scatter plot of X versus W. So if I go ahead and plot that, you see I've got my figures side by side. There are other arguments that we can pass to the subplots method so that we can control the figure size and also could control the labeling of the axes. So here, this doesn't look too bad, having both sets of having the y-axis labeled on both plots. But we might want to share the axis. So in this case, I'm going to say share y equals true. I'm going to set my figure size to be a little bit bigger. I think what I should have really done here is, since these have different scales, is I should have manually set the limits on the axes. So that could be an exercise for you to do on your own. So I'm now going to plot my first set of data. I'm going to set the label. I'm going to provide a legend. Plot my second set of data, and here we go. So you'll notice that we only have the y values listed on the left axis. And we can also do the same thing with the x-axis. In this case, we're doing something a little more complicated. Here, we're generating a 2x2 set of plots. Notice that we're returning, actually, these aren't lists, these are tuples, closely related to lists in Python. And here we're returning a tuple of tuples so that we can create a 2x2 array of subplots. And in this case, you'll see that we're labeling the y-axis just on the left, the x-axis just on the bottom. If I get rid of this, you'll see that things look a lot more crowded. We now have the we now have the values on the x and the y axes for all of the plots. Let me just add that back in. Right. Okay. Oh, I see one thing that happened here is by setting share x and share y, particularly share y to true, the range of values in the x and y direction was automatically set based on the panel with the largest range. So I didn't actually have to set that manually. And that's about it. And I just have a couple commands here at the bottom to show you how to get help. So if I wanted to learn more about the circle method, I just do plot.circle ? Or to learn more about, say, the pi method. So that wraps up the plotting the plotting with Matplotlib and Python. Do we have any questions? I'll give everybody a minute before we move on to the R.
I guess I have a general question, Bob, just since I'm not entirely familiar with Matplotlib. Is in the past I've run into problems when trying to plot too much data in some of these plotting programs, and I just wonder if you've experienced any experience or like feeling for like how Matplotlib does on sort of like really dense data sets that you kind of usually have to like start sampling, but sometimes depending on how it's all configured and things like that, you can kind of run into some issues.
I have no idea. I've never really pushed the limits of Matplotlib where, say, I'm trying to plot, tens of thousands or hundreds of thousands of data points. That would be a really interesting exercise. So
yeah,
that's
kind of like the level that I've run into issues with other plotting programs, kind of tens to hundreds of thousands of plots, data points, just, you know, in a text file, you're trying to read it in and sort of then start parsing it down so you can visualize it. Like, you don't want to like get rid of the data, obviously, but it's like, I don't really actually need all the points, but it's, you know, it's kind of a chicken and egg problem sometimes.
Right. And there are ways for handling dense data. And I see Alexander had posted here. One thing that may be useful for dense data is alpha. And I think I know what you're talking about when you look at data. So one area I worked in was flow cytometry, where you might be plotting, you know, thousands or tens of thousands or even hundreds of thousands of data points. And if you do them all at dots, it just looks like a big blob, but you need a way to indicate that different portions of the figure represent different densities. So that may be a way to do it. And there's a question from Hirokatsu Suzuki. Is there a way to change the size of the figure? Yes. And I did that in this example. So I set fig size equal to 6,6. So let me try, take a look at what I have there. Let's see what happens when I increase that to 1010. And that increased the size of my figure. So nominally, I think that these are supposed to be inches. Or maybe it's centimeters. But yes, you can control the size of the figure in that way. And let's see, another question. Oh, welcome. All right, so with that, I'm gonna stop sharing for a minute. Okay, so it is almost 3:30, it's a Friday afternoon. We've covered a lot of material. So let's do a quick poll. Do you all want to take a quick look at plotting in R using ggplot2? Or do you want to call it a day and say you're happy with Python plotting? Okay, I am seeing at least a few thumbs up, a couple comments in the chat that you would like to see the R. So know what I'm gonna do? I'll leave it all up to you. Feel free to stick around. This is gonna be very quick because we don't have a lot of time left. But if you have no interest in R, or your brain is full after a long busy week, feel free to drop off and I will not be the least bit insulted.
Bob, I'll just add in a comment for the R people before people hop off. Bob will show you, I think, how to do it with the Jupyter Notebook, right? And you can also do it through the Expanse user portal and launch R directly. So there's also that potential use for R. Okay.
Right. Oh, Mary, and let me add, but both in R and Python. So even though we're doing everything here in a notebook, you know, if you're doing work non-interactively, if you're doing batch computing and you want to automate the generation of graphs, you could just take your code, pull it out of the Jupyter Notebook, and drop it into the right place in your application. So.
And Marty, we have Matplotlib command line installed on Expanse, correct?
Yeah.
Okay.
Yeah. I would just probably use we have like a full Conda installation. It should have every package that Bob's used today, I think.
Okay. Thanks.
Right. So thanks for sticking around. I will go ahead. I will share my screen again. We will do a quick romp through R. Started, close that. Okay, so this is going to be very quick, and it is not going to do justice to the ggplot2 package. But for folks who are really into visualization, they love ggplot2. GG comes from the from a classic book in the field of visualization called The Grammar of Graphics. This has been on my to-read list for a long time, and maybe doing this presentation will motivate me to go back and look at it. So we're going to start off, we're going to look at scatter plots in detail, just like we did for Matplotlib, and then maybe look a little bit at some other plotting methods. To me, I find the syntax for ggplot2 to be just just a little awkward. It's not quite as intuitive to me as Matplotlib. And also, I'm going to say that the learning curve is a little bit steeper because ggplot2 works on data frames. Now, I should give a caveat. My R programming skills aren't as strong as they should be, and maybe there are ways to use ggplot2 with vectors or lists of data, but I've always used with data frames. And plots are built up by adding successive layers. So you could think of taking a layer and continuously painting things on top of it. So we're going to look at an example, one of the toy data sets that comes with ggplot2, and that is the MT cars data set. So first of all, we're going to require ggplot2. If you're not an R programmer, this is the way that you load a package. You could think of this as being the equivalent of Python's import. We're going to take a look at the MT cars data set. Just the first few rows. Actually, it's very small, so let's just do the whole thing. So this gives us some information on various cars. It gives the miles per gallon, number of cylinders. I guess that's displacement, horsepower, and a bunch of other things that I don't know because I don't know a lot about cars. I'm going to set one parameter first so that the graphs are a convenient size. You know what? Let's make this a little bit bigger here. I'm setting the size of the plots. And now, with these plots, we're going to be using the ggplot method, and then we're going to be adding things to that. So we're going to add the point geometry. So, and in the R syntax, this arrow, the less than followed by a hyphen, is one of the assignment operators in R. You could also use an equal sign. But for some reason, in the R community, they like to use the arrow. Let's go ahead and plot. So there we have a basic scatter plot. Automatically labeled the axes. Syntax, it takes a little getting used to here. So we have the we're working with the MT cars data frame. AES. That stands for aesthetics. And in this case, we are using the horsepower column along for the x-axis and the miles per gallon column for the y-axis. So if we go back here, you will see that those are column names for our data frame. So we got a basic scatter plot. Couple of things to note here is that we save the plot as G. So here is here's our figure object. And then to actually display it, we use the plot function. Mentioned already that the data frame is the first argument to ggplot, and then we use an aesthetic mapping, AES, so that the horsepower and miles per gallon columns serve as the X and Y data. And then we use the geom_point function to add a scatter plot layer to the graph. So starting with our previously saved plot, notice that if I don't want to, I don't need to start from scratch. I already specified the data that I'm going to be using and the scatter plot using geom_point. Here I'm going to add, and literally, as I have a plus in here, I'm literally going to add a labels object. So here I'm setting the title, the subtitle, an x-axis, and a y-axis label. And so there we go. You see that we have our, right here, we have our title, our subtitle, and we've relabeled the x and y axes instead of using the names MPG and HP from the column labels. Okay, brief digression, getting math formatting into figures. Unlike Python's Matplotlib, ggplot2, or at least to the best of my knowledge, doesn't have a convenient way of formatting math equations and characters using LaTeX syntax. It would be great if they did. Instead, though, it provides some limited functionality using the expression function as demonstrated below. So here's a case where for my X label, I'm using, I'm evaluating omega plus lambda squared as an expression. For the Y label, alpha minus beta. Again, it's much clunkier, it's much more clumsy than using LaTeX, but I'm not aware of any way to get that in. So let's go ahead and give that a try. And there you can see that I have that I've got my Greek letters in the axis labels. Okay, second brief digression. R could be a little funny when it comes to lines that are, when it comes to code that's broken over multiple lines. And the way R works is that if no more arguments are required and all open parentheses are matched with closing parentheses, R will consider the expression complete. Otherwise, it will assume that there are additional content coming for that line. So I just show this explicitly here. The graph that we generated earlier. Just like Python's Matplotlib, ggplot allows you to tune the marker colors, shapes, sizes, and alphas. So here, instead of calling geom_point with no arguments, I'm going to set a color, a size, a shape, and an alpha value. And you probably wonder what is shape 17? And I don't know the reason for this, but the cookbook for ggplot that defines what all of these shapes are. So I'm trying to remember what a 17 was. Okay, triangles. You can, and this is a great feature. geom_point function also lets you vary the symbol properties based on the value of another column. And the reason you might want to do this is so that you can get, so you can essentially plot more than 2 data sets on a 2D figure. So in this case, we're going to set, we're going to set the size of the marker so that it reflects the weight of the car. And we're going to set the color so that it reflects the number of cylinders. So we'll go ahead and plot this. And you can see that we're now effectively displaying 4 types of data on a 2D plot. We have our miles per gallon and our horsepower as our X and Y axes. We use the size of the markers to indicate the weight of the vehicle, and then we use the color to indicate the number of cylinders. And then finally, let's add one more factor, and here we're going to let the shape reflect whether or not the car has an automatic transmission. So there we go. So now we have, let me make this a little bit wider. Okay, makes it a little bit easier to read. So now we've effectively displayed 5 different types of data within a single scatter plot. We can change the axis limits. So here we're going to add one more feature onto our plot. We're going to set the X lim and the Y lim. And I know I'm going through all this pretty quickly, but if you're interested, you could go through my notebooks at your leisure. So here we've manually set the limits so that now our axes start at 0. ggplot2 is fantastic when it comes to working with color. There's a whole set of color palettes in the R Color Brewer package. So we're going to have to load this additional package. You could get information about these color palettes here. And we're adding one more feature to our graph. And that's, we're going to use the Dark 2 color palette. And then finally, we can add smoothing layers to indicate confidence intervals. This is something, again, that you're going to see very, very often in the biomedical literature. Good. There we go. So we're able to do a curve fit here of mile per gallon versus horsepower and confidence intervals. And we can change the smoothing method. So I'm not going to get into that at all. That's getting a little bit more into the statistics of the data. And then finally, we're going to go one step further, and we're going to change the axis ticks and the tick locations. So with these next two lines, we're going to specify the location, the first tick, the last tick, and their spacing. And there we go. So with ggplot2, just like Matplotlib, and maybe even a little bit further, we have fine-grained control over all the properties of our graph. And don't worry about this gray background with the white hashing. That's just for display purposes. I forget how to turn that off. But when you actually print this graph, when you save it to a file, all of that will be, that will just appear as plain white background. So we just scratched the surface on ggplot2. I'm kind of a newbie with ggplot2 compared to Matplotlib, but it's incredibly powerful, gives you very fine-grained control over all of the aspects of your figure. So although it feels like we may have gone to depth, we've barely scratched the surface. So I'm going to suggest if you do use this, master the fundamentals of ggplot2 and incrementally build up your knowledge, bit by bit by experimenting with the plotting methods. And one more thing is, if you are going to experiment with ggplot2, keep in mind that it comes with many built-in data sets that you can use for your experiments. So I'm just going to do a list of them here. So you see lots of cool data. Diamonds is one that's used frequently. It describes the prices, shapes, cuts, clarity of different diamonds. There's a lot of economics data, information on presidential terms, taxes, housing, statistics on hair and eye color, and so on and so on. So lots of things to experiment with. And with that, I'm gonna skip doing the box plots and the bar charts. I'll just display them without going into any detail. Again, we're using ggplot2. In this case, we're going to add on the box plot rather than the scatter. So this way we get box plots of the data. Middle line shows the average. The top and the bottom of the box, I believe, are the The first and are the 25% and the 75% quartiles. The ends of the lines are the first and the fourth quartiles, and any outliers are shown as individual data points. And if we like, we can also plot all of the data. And then we'll just show that we also have a bar chart method, histogram method. And although I don't usually do my plotting and charting in R, one thing that I found is really, really helpful that I didn't find quite as good a way to do in Python is heat maps. So here we're showing data. I believe this is on the cost of housing by county in Texas. So in this case, using the tile function and the scale fill gradient function, we're able to generate some very nice heat maps. And then finally, last thing I'll show is that it's pretty easy to generate multi-panel figures in R. We'll just take a moment to load. So like we did before, we can lay out a grid of figures. Here, GH and GB, these are individual figures that we generated earlier, and now we're just arranging them into a grid. We could also arrange vertically, and as before, we can lay out in a in a 2x2 grid. So I know we went through that pretty quickly, but just wanted you to get a quick look at the ggplot2. So any questions? Well, if that is it, I'm going to wrap things up. Thank you so much, everybody, for coming today. I hope you all got at least a little bit out of the presentations. Again, going a little bit fast, but you have access to the notebooks. You have my email address. In fact, I will type it in one more time. So if you have any questions, I am happy to answer them.